Alright, so chapter 9 is our introduction into like our testing to see whether or not something is true or whether something is false. So keeper 9.1 is the basics of significant tests. Alright, so first thing we need to know, what is a significance test? Is basically a test that compares two things. So for instance, we see it a lot, or I think about it a lot when I'm at home watching TV and I see like commercials that say, 95% of the people lose weight with this weight loss pill or something like that. Well, the significance test is basically a test to see whether or not that statistic was true or false. Alright, so you have two things. You have your null hypothesis and you have your alternative hypothesis. Your null hypothesis basically is the statement of no difference. In other words, we're saying that what the person is saying is true. Like if they say 95% blah 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 lose weight with this weight loss pill, well, the null hypothesis is that that proportion of people p equals 0.95 or something like that. Like we're saying that there's no difference from what they're saying. Now the alternative is what you're actually trying to find evidence for. So if you think that less people lose weight using the pill, or whatever the example is, you can say more or less or just different. Well, that's your alternative hypothesis, is what you're actually trying to find evidence for. You started off with some claim, you disagreed with that claim, so you're trying to find evidence for what you believe. Alright, so our null hypothesis will always be set up as whatever your parameter is. Again, that's your population parameter. Whatever that is, it equals some value, some number. The alternative hypothesis, again, because it's what you're thinking or what you're deciding, that can be, less than what they originally said, or greater than what they originally said, or just flat out different from what they said. So we have two types of tests. We have a one-sided test and we have a two-sided test. A one-sided test is when your alternative hypothesis is either less than or greater than. Like I just want one side. I want to find out if it was less than what they said, or I want to find out if it was greater than what they said. Versus your two-sided test says, I don't care if it's less than or greater than. I just want to know that it's different from what they said. I'm not sure if more people lost weight or less people lost weight. I don't know, but I just don't believe them. I just feel like they're a liar, so I'm going to test a two-sided test. Alright, so your p-value, and a p-value is basically what we use to determine whether or not it's a lie or if it's the truth. And your p-value is basically the probability that of getting whatever result that you get. Excuse me, the probability of getting whatever result that you get when you run the test or when you do a simulation is the probability that you would get that result given that the null hypothesis was true. So if the null hypothesis is true, for instance, let's take like a basketball player. Let's say I'm the basketball player and I said that I can shoot 70% of my free throws. Well, you want to run a test to see if I'm telling the truth. So you take me out to the court and you have me shoot 100 shots. Well, let's say I only got 60% of them in. The p-value tells you the probability of getting that 60% given that you were truly a 70% shooter. Alright, so it's testing the probability, it's looking at or it's giving you the probability of getting whatever you got when you simulated the experiment, given that what they originally said was true. Alright, so if your p-value is if your p-value is small, then you have evidence to reject the null hypothesis. In other words, if the p-value, if the probability comes out really, really small, well, then you say you're a liar. Right? The probability of you shooting 60% when you said you were a 70% shooter is so small that you have to be lying. But if the probability or if the p-value was large, well, then you say, okay, well, that could have happened. You could have shot 60% given that you were a 70% shooter. That's possible. So I'm not gonna call you a liar. I still don't know if you're telling the truth or not, but I don't have evidence enough to call you a liar. Alright. Alright, so basically to wrap it all up, just in like what we're doing for the entire rest of the year, we're going to get some p-value, we're going to find the p-value, and we'll get formulas for this as we go, but we're going to take some p-value and we're going to see if it's small or large. If it's small, we're going to reject the null hypothesis. If it's large, we fail to reject the null hypothesis. Now notice, we never accept anything. Alright, I'm not accepting it, I'm just saying I don't have enough evidence to reject it. It's like almost like in a court of law. Let's say that you do a crime and you go to the courthouse and you have your lawyers and the jury and everything else. Either you're guilty or you're not guilty, or you know, like for instance, if they find you guilty, they found strong enough evidence to lock you up for the crime that you did. But if they say that you're not guilty, it's not that you didn't do the crime. It's simply that they didn't have enough evidence to convict you. Alright, so you want to remember that. Like, it's not that it's a lie that you proved them to be telling the truth. You didn't prove them to tell the truth. You just said, I don't have enough evidence to go against what you're saying. Now remember, you always reject or fail to reject your null, and you always conclude in terms of your alternative. So I reject my null hypothesis and I conclude in favor of my alternative. But if I fail to reject the null, I cannot conclude in favor of my alternative. And you always say that in context. Alright, so again, just to go further with this p-value idea, if your p-value is smaller than the alpha level, now your alpha level is basically like the cutoff that you set prior to running the test. So the alpha level could be like 5% or 1%, like how much leeway are you going to give this person that's making this claim. So if your p-value comes back smaller than your alpha level, well then again you reject your null hypothesis, and we say that data is statistically significant at the alpha level. So again, if it's smaller than alpha, then we say it's statistically significant, and then again we reject our null and we conclude in favor of our alternative hypothesis. So again, this just sums it up again. P-value is less than the alpha level, you reject. You reject the null, you conclude the alternative. But if your p-value is greater than or equal to your alpha level, you fail to reject the null and you cannot conclude the alternative. Well, the issue is that when you do these types of tests, you have a chance of getting an error. For instance, in the court of law, if you were on trial for killing somebody and the jury finds you guilty, well, if you actually did it and they find you guilty, well, that's a good thing. But there is a chance that you didn't do it and they found you guilty. That's a bad thing. Similarly, I mean, I could look at the other way around. You're on trial for killing someone and the jury finds you not guilty. Well, if you didn't do it, that's a good thing. But what if you did do it? Now I'm putting a killer back on the street. So that's kind of the same type of idea that we have here. We have two types of errors, a type 1 error and a type 2 error. Alright, so your type 1 error occurs when your null hypothesis was true. So it was true what you said. You said you didn't do it and that was true. But I rejected you. In other words, I said that you were guilty when you weren't guilty. So then you have your type 1 error. Now you could also have a type 2 error where your null hypothesis was false and I failed to reject. So for instance, like what they were saying, whatever the person was doing, they were lying about it, but I didn't say they were lying. I said they were telling the truth. All right, so that's your type 2 error. Now the way I remember this is fail to reject is a type 2 error. All right, so again, fail to reject, type 2 error. Type 1 error is just reject the null. Alright, so what you need to understand about these types of errors is the probability of getting a type 1 error is the same as your significance level. Whatever you set up at the beginning of the problem as your cutoff, your alpha level, that's the same probability of getting your type 1 error. So alpha level equals type 1 error. So again, that's the probability that the test will reject the null hypothesis when the null hypothesis is actually true. Now for your type 2 errors, we have what we call power. Power is basically the probability that the test will fail to reject the null when the null hypothesis is actually false. So the probability of getting your power is 1 minus your type 2 error. Alright, so again, your power basically is just telling you how strong your test is against the alternative hypothesis. Alright, and that's it.